it is. And it's combined with the gas chromatography. So it's called the GCMS. First, it goes through the gas chromatography. Once it's separated, each separated part goes through the mass spectroscopy, so you know what each separated part is, and it'll tell you if it's cocaine, crack, or whatever else it might be. So you might start with these presumptive tests, then you get it through the GCMS, which is more conclusive. So very briefly, how immunoassays work now, how we get this antibody to fight this and this drug only. Very briefly, animals, they fight off foreign antigens, including drugs. So we take a drug, usually connect to a protein so we can catch it easier, work with it more easily. Never mind. But you take the drug, put it into a rabbit. The rabbit will naturally develop antibodies specific to that drug. Now, again, these antibodies might interact with other drugs, but usually it's mainly for this specific drug. And so the rabbit can get rid of this thing. The rabbit doesn't like the drugs either. So the rabbit develops antibodies to fight with it. We remove the antibodies from the rabbit. We say, oh yeah, now we know what we can use to bind specifically to this drug. So what we do then is we take these antibodies and we take this sample. We don't know what drug it is. Let's say we suspect it's this drug. And we put this antibody in let's say, one place over here. We put the suspected thing here. We let them flow together. If right when they flow together, they develop some kind of dark spot right over here, that means the antibody over here is reacting with this drug. That means that antibody was designed to interact only with this drug, is actually interacting with this sample. Must be there's that drug in this sample. That's generally the way these immunoassays work. They're presumptory, and we try to confirm them with a GCMS, the gas chromatography, mass spectroscopy, because the mass spectroscopy tells us exactly what we have. Thin layer chromatography, as mentioned before, let's say we put our sample over here. Here it's in some kind of solvent that flows upward through this, let's say, it's actually like a layer of powder glued to or stuck to some like a glass plate or a ceramic plate. As this flows up, the different components, let's say one of them flows up this much, the other one flows up that much. This shows that there are two components here, and there's some leftover component here that didn't flow at all. Some flows, again, this one flows a lot faster than this one, so it flowed farther. This one barely flowed at all. So we know there are at least three components. That's what thin layer chromatography is mainly used for, to tell us how many components there are in our sample. Gas chromatography is when a gas, it's turned into a gas and pushed through a column. And this will enable you to see all the different components, because each different component sticks to the column in a different way and will flow out at a different time. And we can see how by the time each one flows out, so we'll know what they are. We can't necessarily identify one thing, and only one thing will flow out at that time, in that time frame. Nevertheless, we get a good idea of what it would be. These are, as we said, presumptive tests. But what we need is another test. Once we separate them using this gas chromatography, we have to analyze it either using the mass spectroscopy or infrared spectroscopy, which will also tell us exactly what the thing is. So these are presumptive, and these other tests are conclusive. They tell you exactly what it is. But we really want to separate them first so we can figure out what to test them for and find out what they are. We don't want other things interfering. So this is what the forensic toxicologist would do. They would, let's say, oh, I got my sample. I'm going to throw it on a TLC, thin layer chromatography. I see three different things. Well, let's see what the gas chromatography would be. They throw it through there. They find the three different things. And, hey, wait, this is codeine, this is heroin, and this is fentanyl. So now I know. Now this might not prove it's only heroin. Maybe there's one or two other things that might also come out at the same time, but they know pretty much it's probably heroin. So then they're going to use the mass spectroscopy on it, or infrared. They analyze each component. Let's say this one and this one and this one. They analyze this one with IR. They say, oh, that's codeine. This one, oh, that's heroin, and this one, oh yeah, that's fentanyl. Assuming that's the way these things came out. So they can find, once they do that, they know exactly what it is, and this is conclusive, and this stands up in a court, and it's very hard to fight with it once you get all this done. Lawyers are going to say, well, you did it wrong, or you're a racist, and you were trying to make the guy guilty. These things have happened all the time in courts, So, but you can't fight with the science, you might fight with the people. Anyway, this is the way forensic toxicologists try to find the drug or the poison that was in their sample. So as mentioned, you need confirmatory tests. The most widely used is the GCMS, the gas chromatography mass spectroscopy. The separation done by the gas chromatography, that's in the column, they're separated. And once they're separated, each one is analyzed with a mass spectrometer, and that will identify what it is that was separated. So that is the typical way that they do it. Incidentally, the gas chromatography mass spectroscopy, this works with even tiny, really minuscule amounts, even in the nanogram scale. These things are really, really good. They've been developed so that they are very good at identifying really tiny trace amounts of compounds that we want. Now, testing for drugs from samples, even though they are trace amounts, it's not just done for criminal forensics, it's also done like the military or sports teams. They want to know if people are on drugs. The military is not going to accept people if they're on drugs. Also, people who life insurance policies, the people who sell you them, the life insurance companies, they don't want to sell insurance to a person who's taking drugs. They'll take drugs and die the next day, and then life insurance policy people will have to pay for it. They don't want to do that. So they want to see, are you on drugs? So a lot of people, even not in a criminal sense, they really want to know how what's in the samples. So often these people they demand urine samples to test. Now I've heard some horror stories about how people have fooled them by giving somebody else's sample. In sports they do it. I've heard of people doing it for their life insurance. It's unfortunate people cheat, but it's a problem. How do you know it's only the subject's urine? Do you have you want the man? Maybe he used his wife's urine because he is on drugs and his wife is not. Something like that. So how do you know? Do you have to witness the sample taking? I mean, it's true for sports too. One person says to his buddy, I just took cocaine last night. I don't want them to know. How about you share some of yours with me? Of course, his buddy, if he's completely honest, might not do it. But if he's not completely honest, I mean, he doesn't need his own urine. Of course, he'll share it. I mean, why not? So, how do you make sure it's only that person? I mean, the best way to do it is to witness it. But could you imagine requiring a witness, especially of the opposite gender, as might be? Okay, let's move on. Let's get out of this. Anyway, so to prove, however, let's say in the military, the sports situation, to prove that they're on drugs, then these simple screening tests are probably not enough. You do need the confirmatory tests as well. If you just want to not let them get the job, then the screening test is good enough. Usually because you don't have to give them the job. But if you want to prove their guilt, then you do need a confirmatory test. Other things that are done are on hair. This is a good thing because hair it sticks to hair. I mean, in the system, it doesn't stay for more than a day, 2 days or so. Even in urine, after about 3 days, old drugs are going to be flushed out. So, but in hair, once it gets in the hair just grows. It doesn't fall out of the hair, especially if it's like in a solid deposit. So blood gets into, hair comes from hair cells. Blood nurtures the hair cells so they can divide, so they can grow into the hair. So the blood has the drugs. Blood doesn't want the drugs. I mean, it tries to get rid of it in whatever way possible, through the urine, through the liver.